How did the Earth appear 1 billion years ago? The moment life ended, numerous significant events have shaped our planet over the years. The spectacular trajectory of biological evolution is amply recorded in the fossil record from the Cambrian explosion of life, which occurred around 540 million years ago and marked the appearance of the majority of animal forms through the rise and extinction of the dinosaurs. But the Earth has also seen a number of less well-known and obscure geological periods. We want to inform you about a lengthy time in this movie that is virtually entirely devoid of fossil evidence. This isn't because we can't identify the rocks where life would have left its footprints. Rather, it's because all geological and biological processes appear to have stopped or significantly slowed down over the course of many billions of years. Even on a geological scale, a billion years is a long time, more than 1/5 the age of the Earth, so where did it come to an end? How is it that we have such limited knowledge about it? We can't reveal any details, but you should be aware that the billion-year time span we're discussing started in the middle of the Proterozoic era. What can we say about it? A period of darkness or a historical void? The magnificent book of Mother Earth's missing chapter? There is no need for concern. The name that it merits has already been considered by someone before us. Yet how? Simply keep watching the video to find out. To focus on dates and circumstances, though, allow us to first bore you with a brief history of Earth. You really should believe us. You should be aware that the Earth was a sort of glowing ball in a molten condition for the first 600 million years during the aeon known as the Hadean. Later, during the Archean Eon, as the Earth's surface cooled, it enabled the development of continental plates and a crust, as well as the buildup of a significant volume of water that eventually resulted in the formation of the first seas. The first life forms, known as prokaryotes, emerged as early as 3.7 billion years ago. More complex single-celled organisms, such as eukaryotes with nuclei and the first multicellular forms, did not emerge until the Proterozoic era, which lasted from 2.5 billion to 541 million years ago. And the Proterozoic era, which is where our story starts, was in the middle of it. Beginning with those countless billions of years, of which so little is known. The flatness of the Earth's surface, both altimetrically and environmentally, would be the feature that most surprised us if we could travel back in time to survey the surface of the Earth a billion years ago. In actuality, we wouldn't see any vegetation, mountains, or hills. Not to mention the complete lack of insect flights, bird songs, and those sly motions in the undergrowth that we are used to seeing during our modern-day forest walks. A thicket, incidentally, did not exist because even advanced plant life had not yet evolved. Therefore, not only are there no tall plants, but also no shrubs or grassy tufts. Nothing. I say absolutely nothing. The only life was little and primitive, existing in a kind of ocean slime made up of cyanobacterial filaments that had difficulty colonizing even the damp soils next to the beaches. As a result, the amount of oxygen in the atmosphere was only a tenth of what it is now. We would have needed oxygen tanks similar to those on Mars in order to move on this undeveloped planet. The land was primarily located on Rodinia, a supercontinent that was disintegrating into an archipelago of huge islands grouped around the equatorial belt, with oceans covering 80% of the planet's surface at the time. In essence, the world in the distant past resembled a desert whose beaches were pummeling by violent storms that broke volcanic rocks, creating the earliest sedimentary layers and sandstones. The moon was just 350,000 kilometers from our planet, as opposed to 384,000 kilometers today, which resulted in enhanced tidal effects, and the Earth rotated quicker than it does today, making the day only 18 hours long. An alien explorer who visited Earth in such distant time would have likely returned, putting it among the barren, deserted worlds undeserving of any mention in his logbook because life was limited to the oceans in the form of greenish algae. There isn't much proof that the climate changed significantly throughout this time. There is no proof that Earth's climate was noticeably colder, even though the sun was 10% less light than it is today. If there was, it did not depend on the brightness of the sun. The planet was likely a little warmer in reality. In other words, the Earth appeared to be frozen in place at first. Nothing was altering, everything was withering while it was being born and growing. As was previously mentioned, the amount of oxygen in the atmosphere and even a large portion of the world's oceans was significantly lower than what we breathe today. As a result, the seas appeared to be inhospitable bodies of water that were rich in iron or toxic hydrogen sulfide, the foul-smelling gas released by rotten eggs. The eukaryotes, the earliest single-celled organisms, had been developing for some time when evolution suddenly seemed to stall as though nature was unsure of its next move. Everything was stale, sterile, and unsuited for survival. There was no freezing or warming. However, there had been a little bit of everything going on both before and after this extremely peaceful time. When cyanobacteria first appeared, 2.5 billion years ago, the Earth had just experienced the wonder of life. Cyanobacteria are microscopic algae that can manufacture energy by exhaling oxygen as waste. By creating a shield against damaging radiation and permitting the emergence of new creatures able to survive in its presence, this allowed the atmosphere to become enriched with oxygen. These included the bacteria known as heterotrophs, who were forced to evolve into hunters since they were unable to manufacture their own food, eventually giving rise to the animal kingdom. Instead, autotrophic species were responsible for the development of the plant kingdom. What a revolution, in your opinion? And that's all there is to the past, but even as the quiet period came to an end, amazing things began to happen. In fact, the Cambrian, or Renaissance, period started, during which the Earth quickly changed from being inhabited by immobile, single-celled organisms to being home to the sophisticated, bizarre, and complex life forms that have since evolved into the ones we see today. Nothing in the midst of these revolutions. For a billion years, nothing. Due of all of this, scientist Roger Buick paraphrased Winston Churchill's famous Battle of Britain quote, which goes, "Never in the field of human strife was so much owed by so many to so few." Instead, Buick stated that there had never been a time when so little had transpired for so long in human history. Using poetic license, the late paleontologist Martin Brazier would later come up with the catchphrase "boring billion" to refer to the same time period. A definition that, from that point forward, would permanently cement itself in all geoscientists' minds. However, what could have possibly made a billion years appear so boring? The extraordinarily long time of no change has, of course, given rise to a number of theories. The majority of experts claim that the tectonic movement of the Earth's crust is stagnant. Although it sounds difficult to understand, this idea is simple. It actually makes sense when you take into account how our planet's surface is continually being reconfigured, as if in a slow-motion dance, by the unceasing movement of tectonic plates. The Himalayas and other mountains like them that continue to grow into the sky are the result of collisions between continents that harden the crust. Additionally, if tectonics for any reason abruptly slows down, mountain range formation will also be halted. The continent of Rodinia was entirely flat, lacking any rising mountain ranges, as we have previously stated, and this had another dramatic effect during the boring billion years. All those essential elements, most notably phosphorus, which are required for the origin and development of life, could not be brought into the oceans by rivers if there were no more mountains to erode. To put it simply, by starvation evolution came to an end. Not only that, but fewer creatures also had another effect, a dramatic drop in atmospheric oxygen that persisted for the duration of the bored billion. In essence, the oceans were decaying and gasping, and the few microbes that were still alive were unable to create as much oxygen as they formerly had. But another element might have also been important. According to current research, the Earth's magnetic field underwent a dramatic transformation and major decrease some 1.2 billion years ago. We now understand that the planet's core is what creates the magnetic field of the Earth. It shields the living from cosmic radiation and other particles, making it a genuine shield. However, it is still impacted by the somewhat unpredictable weather in space. The Earth's magnetic field appears to have remained active for the majority of the planet's history and without experiencing significant fluctuations in strength, according to rocks that have preserved its history. The single exception occurred near the end of the Precambrian, concurrently with the bored billions and decreasing ocean life. It seems like a little bit too much of a coincidence, doesn't it? In other words, the Earth would have transitioned from having a strong magnetic field with two opposite poles at its north and south poles to a weak magnetic field that fluctuated in strength and direction between different poles about 1 billion years ago, before returning to normal at the end of the tedious billion. The increase in UV radiation brought on by the weakening of the magnetic field may thus have helped the extinction of life on our planet. In fact, by deflecting energetic particles from the solar wind and cosmic rays, the magnetosphere produced by the Earth's magnetic field played a crucial influence in the evolution and maintenance of life on Earth. Because of this, Earth's atmosphere has been preserved over time, unlike, for instance, Mars, where the planet's atmosphere was essentially blown away by the solar wind due to Mars' weak magnetic field. The entire Earth's ecology started operating again as soon as the magnetic field was stabilized. After being first weakened by cosmic rays, life started to spread, tectonics got going again, feeding the oceans properly, and marine animals started producing the amount of oxygen that would eventually kind of propel Earth into the Cambrian explosion of life. I sincerely hope you guys weren't bored.